Hello. So let's look into today's Leetcode problem, which is minimum obstacle removal to reach corner. So in this question, you are given with an m cross n matrix, and each cell present in this matrix are represented by either 0 or 1, with 0 being empty cell and 1 being an obstacle. You are starting from top left corner of the cell and you want to reach the bottom right corner of the cell. You are allowed to move in all four directions, that is up, down, left or right, and in the end what you want to return is the minimum path. By minimum path, what I mean is the path which has least number of obstacles. So let's take this example and understand about this problem a little more. So here this is our input, and the output for the solution will be 2. And by looking into this example itself, it is pretty obvious, because there could be many number of paths that you can take, but this path should be optimal, because on the way you are encountering a total of 2 obstacles here. If you try taking this path, it has a total of 3 obstacles, but you want to return the path with minimum obstacles. By returning the path, I mean returning the minimum obstacles only. And do we have a better path? We can go this way, but okay, by taking this path as well, you will be returning -2. So in this question, you are only asked to return the minimum obstacles. That's it. So the question should be clear by now. And if you go and read this question few times, then one solution should pop into your mind. So here you are starting from a position, you are going to reach a position, and for each position you have the option to explore all four directions, all four ways. So and the other thing is you want to return the minimum path. So exploring directions, returning minimum values basically constitute a DP solution. And in the initial attempt, I tried a DP solution and it failed because of TLE for a very big input. And it will pretty much be obvious, because for a big input you will need to have a bigger DP array, and that too in this problem I used a 3D DP array, 2D for storing the I and jth position, and also we have something called obstacles. I don't really want to completely walk you through the code, but let's look at it quickly and reach to an optimal solution. So here what I do is, whenever I return the destination cell, I return the total number of obstacles, and I do traversal over all four directions and do the traversal and store the minimum of all four possibilities and then return it. And in this DP dynamic programming call, I am also passing a variable called obstacles, which will basically be the total number of obstacles encountered so far in the path. So this is how the DP solution looks like. But let's try to look into the problem again. So here you are given with a fixed starting point. You want to reach a fixed ending point, and though you have the liberty to go to all four directions don't have the same cost. And by cost, what I mean is all four directions might have obstacles, might not have obstacles. Some of the paths might have obstacles and some might not. So let's think about these obstacles as the cost. If you are going to that cell and if you encounter an obstacle over there, so it will take you a unit cost to reach that cell basically. So whenever you encounter an obstacle in your path, you treat it as a edge weight to that. So you are given with a fixed starting point, you are given with the cost to reach a neighbor, and you want to go to the final destination. So it pretty much resembles a graph problem here, and if you are having a fixed starting point, then Dijkstra algorithm should be the way. So that is what I have used in the solution. So let's quickly go through the solution as well. 1 1 1 1 1 1 0 0 and 0. You start from this position, you put this position, that is 0 comma 0th position, and the total cost to reach that position should be 0, and you start exploring all four directions. So this direction is not, these two directions are not possible, so you explore the remaining two directions here. Initially we will be setting a 2D array for cost as well. Let's consider this array as cost itself. So the first cell will always be 0 because we are starting from that cell, and remaining all cells will have a total cost of infinity. So what you do is you try exploring all possible neighbor of popped element. So here let's say if you want to go to this cell, and you find its cost. Right now the cost to reach this cell is infinity, and the cost to reach this cell plus the obstacle is basically 0 plus 1. 0 plus 1 is obviously lesser than infinity, so we update the cost to 1, and then push it to the priority queue, that is 0th row and first column with a cost of 1. And similarly for this cell as well, you will be doing the same, first row 0th column with the cost of 1. So whenever you encounter an obstacle, you add that to the cost, and check if the current cost is greater than or less than the cost that is inculcated during the traversal, and do relaxation accordingly. And in the end what you do is return the cost of the destination cell. So that's the code that I have written here. I have initialized a 2D cost matrix with int max has maximum value present over there, and definitely the starting node will have the cost set to 0. I am pushing the index along with its cost, and when you apply Dijkstra algorithm, and if you want to find the minimum cost, you should basically use min heap. That's why I've written a comparator over here. Okay, so next is we are exploring all four directions. So you pop the element out of priority queue, explore all four valid directions, all four valid cells, and see if you have an obstacle or not. If you have an obstacle, then you store it in this local variable. Then what you do is basically a relaxation of edges. If relaxation happens, then you push the neighbor into the priority queue with its cost and do exploration, and in the end what you do is return the return the cost, minimum cost to reach the uh, final index. Yeah, so that is what we want in this question. So yes, thanks for watching. Bye bye.